Okay, what we're going to do right now is we're going to work on a little bit of a trig overview and review. So just want to go over a few basic things from the beginning. So one of them is trigonometry is always going to be dealing with the right triangle. That means every single right triangle we're going to work on right now with trigonometry is going to have a right angle in it. So that's the first thing. They all have exactly one right angle. There are two acute angles. So the three angles inside of a triangle add up to 180. That means these two angles have to add up to 90, which means neither one of them can be equal to or greater than 90. So we're going to have two acute angles. And like I just said, all three angles add up to 180. And that's true for all triangles. So the three angles sum or add to 180. So 90 plus alpha plus beta gives you 180. Now, as far as identifying the sides, I mean, you can identify them with just the letters, but it's going to be much more useful. I mean, we'll need to make sure we keep track of the letters in the, in which to identify which side it is in the problems. But it's going to be extremely important when we get to the actual trig ratios to be able to identify the opposite, the adjacent, and the hypotenuse. And so the hypotenuse is always going to be in the same place. Same place in relation to the 90-degree angle. So the first thing you want to do is you want to find your 90-degree angle, the right angle, and you want to go straight across, and whatever side is opposite that 90-degree angle, go straight across the middle of the triangle. That's your hypotenuse. Now, I think it's best to start off with the hypotenuse because that one is going to be the same regardless of, it's going to be the same no matter what angle you're looking at. The other two angles are going to determine which is the opposite and the adjacent. So our hypotenuse is always across, oops, spelled it wrong, from the right angle. Okay, so across is just opposite, the same thing, right? Fifth thing to keep in mind. Okay, the other two sides, okay. Now, when I say the other two sides, I mean the opposite and adjacent depend on the angle we're starting with. Okay, so the angle chosen or the one being used. Okay. So in other words, if we look at angle A, so say alpha, the side that's opposite of alpha is different than the side that's opposite of beta. And so that's just something you need to make sure you keep in mind. So before you can find the opposite side and the adjacent side that you're going to be using in the trig functions, the first thing you have to do is understand what angle you're using. So you have to, sometimes you'll have a choice, sometimes you won't really have a choice, it'll just be one or the other. So the first thing you need to do to identify the other sides first, identify or choose the angle, okay? And then seventh, okay, just make sure you remember opposite. Okay. Usually this one doesn't give as much trouble as adjacent, but opposite is across. And adjacent means next to. That's the word that's a little bit less familiar. So once you get these things straight, so like if we look at this right up here, okay, M is opposite, maybe I should write side M is opposite alpha. Okay, whereas R, so you go across the middle of the triangle to get to the other side, that's the opposite side. So alpha is right here in this corner, straight across this vertex. So if we look at R, R is right next to this angle, right? That's our adjacent. Side R is adjacent to alpha. Okay, so here's our two examples. Choose or start. If you start with alpha, that's what you got. If you start with beta, well, then we start here and we go straight across, and the opposite side is R, so it's going to be switched. So side R is opposite of beta. So notice M, which is this one, is opposite of alpha. R is adjacent to alpha, but R is opposite to beta. And then if we look at side M, M is next to beta. So the word is adjacent. Okay. Now the next thing is, we haven't talked about what it is, but you may or may not have heard this word. It's kind of a strange word. M-N-E-M-O-N-I-C. Now you don't pronounce that M. This is a mnemonic. This word is mnemonic, and what it is it's something to help you aid your memory. So like a little saying, expression. It can be a pattern of words, like PEMDAS. You've heard PEMDAS before. Please excuse my dear Aunt Sally. Now that is an example of a mnemonic. It helps you remember the order of operations. Parentheses or grouping symbols. E for exponents. M for multiply, D for divide, etc. Okay, so our mnemonic that we're going to be using is so, ka, toa. So that's what we're going to use. And so you use this, remember the first letter refers to the function. So sine, that's a C for cosine, T for tangent, O for opposite, H for hypotenuse. Cosine is adjacent over the hypotenuse. Tangent, opposite over the adjacent. And so if we were looking at sine alpha, for instance, that's our opposite. The opposite of alpha is M. That would be M over H, which is our hypotenuse is P. Okay, and so on.